Dear students, today we will discuss the concept of optimization techniques, that is job sequencing. So job sequencing is one of the important concepts in any business organization for managers because they have to manage all jobs in such a way that there should be very less idle time of any resource. Because if any resource remains idle for some time, then that is a loss of that particular organization. So to utilize all resources effectively and efficiently, you should properly sequence the jobs so that the idle time of any machine, idle time of any, we can say, human being will be very less. So to use and utilize assets of any organization effectively and efficiently, this job sequencing is very essential. So today we will see job sequencing problem for processing n jobs on two machines. So we'll see one simple example, and on the basis of that we will explain the concepts of how to sequence the jobs on two machines. Suppose one example given over here, there are 9 jobs having names from A to I needed to be processed on machine M1 and M2 in the same processing sequence. Means what? If job A is assigned to a machine M1 then first you have to assign that job M1 job A to machine M1, and then you have to assign the job A to M2. So the processing order must be from M1 first, M2 second. Then for second job M1 first, M2 second. Okay. Identify base job sequence that will reduce the idle time of machine M1 and M2. Here they have asked you to calculate what is minimum idle time required if you properly select any job sequence. Values given against job and below M1 and M2 are processing time in minutes. So these 3 or 13 indicates that for job A, if you want to process that job A on machine M1, then it will require 3 minutes. Job A to get finished on machine M2, it requires 13 minutes. So these are the time required to process the jobs on machine M1 and M2, and the unit is in minutes. Calculate minimum elapsed time, idle time, and percentage utilization of both machines. So before that, we will see what is elapsed time. Elapsed time is nothing but when you start job for first machine and when you finish all jobs on last machine, what is the time required to complete first job to last job? That time is called as elapsed time. Elapsed time is nothing but total time required to finish all jobs. Idle time is nothing but time in which machine has to wait. Machine has no work. That time is called as idle time. And percentage utilization of means out of total time, how much time the machine M1 or machine M2 is busy. That is called as percentage utilization time. So before solving this example, we should know what is the Johnson's rule, because Johnson's rule is a rule used to sequence the job on multiple machines. That may be 2 machines, 3 machines. There are some other types of examples also, but today we are focusing only on n jobs and 2 machines. So to sequence those jobs, we have to take into consideration job sequencing algorithm, that is called as Johnson's algorithm. Okay, so we'll see what is Johnson algorithm. The first step of Johnson algorithm or Johnson's rule to sequence n job on 2 machines is step 1. Prepare a table with 2 rows and n columns. Here n columns are nothing but how many jobs are there. On the basis of that, you have to create a columns. Give first row heading as sequence and give sequence number from 1 to n in sequence heading row. So this is a table I have added. In first row, I have given heading as sequence and how many jobs you have to process. So in this given example, 9 jobs you have to process. So I have given 9 sequence. Means which job we have to process first, second, third. In this way, you have to create a job sequence. And now you have to identify which job you have to process first, which job you have to process second, which job you have to process second, third. So for that purpose, we have prepared this table. The first row is sequence numbers and second row is jobs. So what is the second step? Find the minimum processing time required to process a job. So from the given example, time required for machine M1 for processing A job, B job, C job. So all jobs, the time is given here. Likewise, time required to complete all jobs for machine M2 is also given over here. So in step 2, what you have to do? We have to identify minimum processing time required to process any job or a job, we can say. So here we have to identify all times required for completing the particular jobs. Among that, you have to check which is the minimum one. Which is the minimum one. So see, if a minimum processing time is for machine M1, so this is for M1, this is M2. If the processing time for time is minimum for machine M1, then write the job number in the leftmost empty cell of a row heading job, and mark that job as scheduled and go to step 2. Means what? You have to check in this case which is minimum value. So in this case minimum value is 2. So this is not for machine M1. So we have to check next. If the minimum processing time is for machine M2, then write that job name in the rightmost empty cell. Means what it is saying that if the minimum value is for machine M1, then you have to write that job number at leftmost empty cell, that may be here. If the minimum processing time is for machine M2, then you have to write that job number or job name at rightmost side. Getting? If machine M1 requires minimum time, then you have to write that job number at left. If machine M2 requires minimum time, then you have to write that job number at right. Third, if the minimum processing time is same for both machine M1, means what? If the minimum processing time is same for machine M1, then now see one case here. What is the time? See here. Suppose M1 is requiring time 11, here is also 11. So both machines are having equal processing time. So in that case, what we have to do? Then check corresponding processing values or processing times required for machine M2. You have to check corresponding times. So for for job I, machine M2 requires 12 minutes, and for job D, machine 2 requires 2 minutes. Okay, whose processing time of machine M2 is minimum, that job name should be in leftmost empty cell of a row heading job. So whose second machines, when the first machine values are same, then you have to check corresponding values on machine of the same job on machine 2. And on the basis of that, whose value is minimum, that job you have to place at leftmost empty cell. Leftmost. On the other hand, same. If minimum processing time is same for machine M2, so if M2 is having same time, M2 machine is having equal time values, then what you have to do? In this case, we don't have equal values, so it is not possible for me to explain the same case. But suppose here there are two values, here is also 8 and here is also 8. Then what you have to do? Then you have to check corresponding processing time required for machine M1. So in that case, you have to check corresponding values for machine M1, and on this, whose processing time is one machine M1 is minimum, that job should be in the rightmost empty cell. So you have to take in mind, if value is minimum in M, if you are comparing values from machine M1, then you have to write that job at left side, and for machine M2 you have to write that at right side. Okay, right side, and mark that job as scheduled and go to step 2. Means once again, once you assign the job number, that is left side or right side, you have to recheck the remaining values. In that case, you have to ignore the cell, ignore the job which is you have already processed, which is you have already sequenced. So that job you have to ignore. Next, if the minimum processing time is same for machine M1 and M2, in this case, if the minimum processing time is same for machine M1 and M2, then check corresponding time required for processing on remaining machines. Identify whose processing time on corresponding machine is minimum. So see what is the case here. Here, suppose value is 9. 9 value is for machine M1 also, and 9% time required for machine M2 also. So in this case, which job you have to process first, whether C or whether Z? Because here when I compare the time values, the time required for both machines is same. So in that case, what you have to do? We have to check corresponding values of machines. You have to check corresponding values of the machines. See, if corresponding processing time is minimum for machine M1, if corresponding processing time is minimum for machine M1, then write that job name at rightmost empty cell, because we know that M1 and M2 both are having same values, and if we are checking corresponding value for M1, then we find that M1 is having minimum value, then M2 job you have to sequence, and we know that if you want to sequence the job on machine M2, then that job you have to write at rightmost side. That's why it is written over here that job name in the rightmost empty cell of row heading job, and mark that job as scheduled. Okay, then next one, if corresponding processing time is minimum for machine M1, means what? Sorry, M2 means what? M1 and M2 both are having same time, then we have to compare corresponding values of machine M1 and M2, and we found that machine M2 is having minimum value. Then that job name you have to write in leftmost empty cell of row heading job and mark that job as scheduled, and go to step 2. Now see, third very difficult condition. If corresponding processing times are equal, if corresponding job times are equal, in this case, see, machine M2 is having 8, machine M1 is also having 8 minute processing time. Now we have to compare corresponding values. Corresponding values also same. Processing times also same, corresponding values also same. So what we have to do? They have suggested that then follow FCFS rule, means the job which comes first, we have to process that first. So in this case, job C has to process first, and then job G has to process. The FCFS rule, and write job names in leftmost empty cell of row heading if processing time on machine M1 is minimum, or write that job name in rightmost empty cell of row heading job. Means what? If M1 is not minimum value, then you have to write that job at the right side. So in this case, see, we were comparing the values of, this is minimum value 8, 8. Now we are comparing values with 9, 9. So both are same. Then what you have to do? First come, first serve. So in this case, C comes first. But C, which is minimum value? Minimum value is 8, which is for machine M2. So we have to write the C job at right side of your sequence. Right side of your sequence. If it is like this way, here is 8 and here is 9. And here is also 9 and here is 8. So what you have to check? If the minimum value is for machine M1, then that job you have to write at left side. Okay. Then last one. If there is the same processing time for machine M1 and M2, for both job, if there is the same processing time for machine M1 and M2 for same job, here this is the case here. Machine M1 is also 10 minutes, and machine M2 is also having 10 minutes. Okay, to process that particular job. Then two job sequences will be formed. In this case, two job sequences will be formed. The first one, if we take minimum job processing time for machine M1, then write that job name in leftmost empty cell of the row heading job. So if you consider, here we have two choices. You can select either this time as a minimum or this time as a minimum. If you are treating this time as a minimum, then you have to write this job number at leftmost empty cell. And if you take this time as a minimum, then you have to write this job name at rightmost empty cell of your job sequencing table. So that is written over here. Okay, so if you consider job M1 is having minimum time, then you have to write that job number at minimum leftmost side. And right, likewise, if you take minimum job processing time for machine M2, then that job name in rightmost empty cell of your cell of your row heading job. and mark that job as scheduled and go to step 2. Every time we are going back to step 2, and in step 2 what we are checking, we are checking the minimum processing time required for the job. So this is your Johnson's rule. So if you are having idea in your mind about Johnson's rules, then it is very easy to solve these problems. Okay, now we'll see the same example now. Actually, we are solving the example. Okay, so this is my example. So in first iteration, so in my first iteration, okay, let me know out of these jobs, which job is having minimum value? So job D, which is having minimum value. Job D, which is having minimum value, and this is minimum for value having minimum for processing time is minimum from machine M2. So as per the Johnson rule, if machine M2 is having minimum value, then you have to write at rightmost empty cell. So that I have written over here D at 9th position, and I have to mark this is finished. This job I have already finished at in first iteration. Then in second iteration, you have to check which is next minimum value. So you can see in this case, the 3 is the minimum value, and this is for machine M1. So this value is minimum for machine M1. So this job I have to assign at leftmost side of your job sequencing table. So I have written over here A. So this is also finished. I have allotted this job with second number. Then third time. See, out of the remaining values, we have to check which is minimum one. So now in this case, this cell I will not take because this job already assigned. Like this way, this job is already assigned. So remaining value is 4. 4 is a minimum for variable for job H, and that 4 minutes is a processing time required for machine M2. So we have to assign that this job to the rightmost empty cell of your job sequence. So this H job I have written over here because this is for already we have assigned for job D. Then available most position was 8. So I have assigned job H over here, and I have to mark that this job is also assigned in third iteration. In fourth iteration, we have to check which is minimum one. So minimum value is now 5. So 5 is for machine M1. So I have to write this B at C. Here is one issue. 5 is over here also, and 5 is over here also. The 5% time is having for two different machines. M1 is also having 5 minutes processing time. M2 is also having 5 minutes processing time. So in this case, what the Johnson's rule says that you have to compare the corresponding values that are required to complete the job on another machines. So for B job, to process this B job, corresponding value required to complete this job is 7 minutes, and for F machine or F job, the corresponding value required is 6 minutes. So 6 is minimum than 7. So we have to process job F. So where you have to keep this job F? In job F, we have to check which is minimum value 5, and 5 is for machine M2. So F value we have to write at rightmost empty cell. Here we have identified F is position for F job is 7th position. So I have to mark this is assigned at 4th iteration. Now in 5th iteration we have to see. Now which is the remain one? This B is remain, which is having value 5 that you have to assign, and this value is for machine M1. So B we have to write at. So the B we have to write at this position. Iteration number 5. In iteration 5, we identified minimum value is 5. So here we have to write. I have assigned 5 over here, and they identify this value in iteration 5. Then check the remaining values, among which is minimum value. In this case, for job C, time required is 9 and 8 minutes. For E, 10 minutes. For G, 8 9 minutes. And for I, 11 12 minutes. So out of these, minimum value is now yes 8. Okay. Now what you have to check? 8 minutes is required for job C as well as job G. So in this case, what you have to check? We have to check corresponding values. So corresponding value for machine C is 9 and for machine G is also 9. Now there is a tie. Processing times are equal, corresponding values are equal. Then to solve this tie, Johnson's rule has given you a solution that you have to check the sequence of jobs in which they are appearing for your shop or for your processing. So in this case, job C appears first and job Z appears at, you can say, next. So first you have to process this job C, and while processing the job we have to check which is the minimum value for whether it is for M1 or for M2 for machine M2. So if it is minimum for M2, then you have to write this job to the right side, because the time required for processing the C job is minimum for machine M2. So you have to write this job C at rightmost empty cell. So in 6th iteration we identified job C you have to process at sequence number 6. So here I have processed this job right here 6. Then remaining is 8, this job. So 8 is a processing time for machine M1. So this job we have to process, we have to sequence in leftmost empty cell. So in this case, leftmost empty cell is this 3. Okay. So I have to write here X 7. So in 7th job, in 7th iteration, we have identified this is the empty value of your, sorry, this is the value we have to, because at 3 we are having empty cell. So this is the right value for your G job. Okay, so in 7th iteration we identified job G is having minimum processing time for machine M1. So we have written that G at 3rd position. Now we have to check minimum values for job E and job I. So here minimum value is 10 minutes. So but here the 10 minutes time is required for machine M1 as well as machine M2. So here two job sequences will be formed. Because you can select this is minimum value. If you are selecting this is minimum value, then you have to write this value, this job at left side. And if you select the minimum value is for machine M2, then you have to write this job at right side. So in this case, we are having 10, 10, same values for same job on 2 machines. So what you have to do in iteration 9, in iteration 8, we can say we can treat this E is having minimum value for machine M1. Then we can write E at, because up to this 4 and 5 these two cells are empty cells. So if you are selecting minimum time for machine M1, then you have to write this in leftmost empty cell. Or if you select this as a minimum value, then you have to write E at this side. So you can say this or this. Your iteration should be this. You can write E at 4th position if you select minimum time is for machine M1. Otherwise, if you select minimum time for machine M2, then you have to write here. Okay, so this is we have completed if there is a tie between times for both machines. So this we have completed in iteration number 8. And last, what is the empty space remain where you have to write the ith job. So here if you select this, this is a processing, this is the one method, then you can write your I at fifth position or I at fourth position. So here we can see the last allotment x, that is x9, because here if you select first iteration number 8, then empty space is for fifth cell, and for second sequence empty space is at fourth position. So if you follow this, then your sequence will be in this fashion, and if you follow this, then for ith job will be at fourth position. Okay, so how this is two sequences will form, because for machine E, job E, the processing times are same for both machines. So if there is a tie between two machines having the same time for same job, then we are coming across two different job sequences as shown in this example. So these two jobs sequence were formed. Now we'll see how to calculate idle time for the both machines. So you have to create one table. We have to create a table in which the job sequence what we have identified. Suppose we are taking into consideration this job sequence first. So which job we have to process first, second, third, that we have identified: A, B, G, E, I, C, F, H, and D. This is the job sequence we have to process. So on the basis of that, we have to, in this case, A, B, G, I, E, C, F, H, D. F, H, D means we have followed this job sequence. We have taken into consideration this job sequence. So you have to write job names which we have identified using Johnson's method in this table. Now we have to write job A, we have to process first on machine M1. So when you start this job on machine M1, the starting time will be 0 minutes. And we know that how much time required for machine M1? Job A required to process on machine M1 is 3 minutes. So after 3 minutes, this job will become free. Then job B will start on machine M1, and at that time the starting time will be 3 minutes, because once we complete the job A, then we are proceeding job B, then proceeding with job G, job I, job E. So out time of machine A will be the in time of machine B. Okay, so at third minute we are starting, after 3 minutes we are starting job B, and for job B we know time required to process is 5 minutes. So 3 plus 5 is nothing but 8 minutes is the can say out time or finish time to finish the job 8. Then 8 will be the starting time for machine G. For machine G, it requires 8 minutes. So 8 minutes to start and 8 minutes to complete. So it will take 60 minutes to complete all A, B and G job. Likewise, you have to calculate in time and out time for all machines. So here I have identified that the last job D will be processed after 17th minute. So minimum 70 minutes the machine M1 will work to complete all jobs. Now see, in this case we are starting the job A on machine M2. When we are starting, when machine M1 finishes his task, then that job we are assigned to machine M2. So this machine 2 will start his duties or his work after 3 minutes. So before 3 minutes, this machine has to wait. That's why we can write 3 as an idle time for machine M2 for first job A. So we have started this machine at 3 minutes. After 3 minutes we can say. And what is time required to complete A job? To complete A job on machine M2, it is taking 30 minutes you can say. So 3 plus 13 3 plus 30, 3 minutes to start and 30 minutes required to complete the job. So total it will take 60 minutes. Okay, now what you have to check? Now I have to process the job B. Actually, the job B is completed at 8 minutes, and machine M1, machine M2 is free after completion of job A at 60 minutes. So 60 and 8 means what? Here, this machine is not required to wait, because when he completes his first job, it will take the second job, because the second job is free at 8 minutes and we are taking that job at processing for after 60 minutes. So this machine doesn't require to wait. On the other hand, if it is the situation that if job B is completing at 18 minutes, suppose, then and job the first machine M2 has finished his work at 60 minutes, then till 80 minutes he has to wait. So here we can write waiting time 2 and here starting time 80. But in this case, this is not the case, so we cannot write that, because this machine is free after 60 minutes, but this job B is already completed at 8 minutes. So we can directly select the out time of the machine M2 for in time as a 16, and we have to process the job B, and to process job B we need 7 minutes. So 60 plus 7 is equal to 23. So here the machine doesn't require to wait, that is no idle time, so I have written over here dash. You can write 0 also. Then third time, as we know that the in time for new job is equal to out time of previous job. So here out time is 23, so I have taken over here 23 as it is, because the job Z is already finished before 23 seconds. If it is completed before 23 seconds, then you have to take the out time of previous machines. If this time is more, then we have to take this time as a starting time for machine M2. Getting? So in this case, 16 is less than 23, so we have to take 23 as it is. So after starting this job Z at 23 minutes, job G requires 9 minutes. So 23 plus 9 is 32. So no waiting time. Like this way, you have to calculate in time and out time for all jobs. And we found that the last job D, which is completed by machine M1 at 70 minutes, and for that you have to process that job after 71th. Means what? Job H required to finish on machine M2, it takes 71 minutes. So 71 and 70, we have to do comparison. In that 72 is more, so we have to take 72 as 71 is as it is. And when we start job D at 71 minutes, and we have to check what is the time required for job D. For job D for machine M2, 2 minutes are required. So 71 plus 2 is 73. So the minimum elapsed time to complete all jobs is 73. So this is the value, that is your elapsed times. To finish all jobs, how much time required? 73 minutes will be required. So this is nothing but your elapsed time to complete all jobs. Then idle time for machine M1. So how much time? Total time required to finish all jobs is 73 minutes. But machine M1 has finished all jobs at 70 minutes. So what is the idle time for machine M1? That is nothing but total elapsed time minus time required to finish all job for machine M1. So elapsed time is 73. Time required to finish all last job of machine M1 is 70. 73 minus 3 is 70 is equal to 3 minutes. So 3 minutes is idle time for machine M1. Likewise, idle time for machine M2 is equal to, for that purpose, what do we do? We have to take addition of all the idle times of required for machine M2. So in this case, addition of idle time for machine M2 is 3 minutes only. So we have calculated idle time for machine M1, idle time for machine M2. Now we will see what is the percentage utilization of machine M1. How much percentage machine M1 is utilized? So that for that formula is elapsed time minus idle time for machine M1 divided by elapsed time. So here elapsed time is 73. Idle time for machine M1 is 3 minutes, and That is total elapsed time is 73. 73 minus 3 divided by 73 into 100. If you do calculations, you will get 95.89% is the utilization of machine M1. Out of total time, how much time we utilize? We have utilized maximum, that is 95.89%, about 96% we have utilized the machine M1. Likewise, percentage utilization for machine M2 is equal to elapsed time minus idle time for machine M2, because we are taking into consideration utilization for machine M2, so we have to take idle time for machine M2. Elapsed time minus idle time for machine M2 divided by elapsed time. So if you put the values of elapsed time, idle time, and if you calculate, you will get 95.89% is the percentage utilization for machine M2. So here we have completed all expectation from your examples. They will ask you to calculate elapsed times, idle time for both machines, and percentage utilization for both machines. So here all values we have calculated. This is about job sequencing of two machines. If you are having any doubts, then you can call me on my mobile number. My mobile number is 98500 98225, and my name is Dr. Babasaheb Mohite. Thank you.